Not yet. Yes.
So today we are going to cover two elements. Okay, so you have to keep calm and love chemistry, right? Today what we are going to discuss is what are alkaline earth metals, natural occurrences, their position in the periodic table, electronic configuration, their physical properties, atomic and ionic radii, ionization energy, and the uses of alkaline earth metals. So today we are going to learn about this. Okay, so are you ready?
Yes, ma'am.
So, do you know which elements consist group to consist of which elements? It
Group
is
2.
hmm, it consists of pe- yeah. Am I audible? Group 2 consists of beryllium, magnesium, calcium, strontium, and barium. This is known as my beryllium. You can check it in your periodic table also. Magnesium, calcium. This is your strontium. Write down the names of group 2 elements in your notebook. And last one is barium.
Okay.
Done writing?
Yes, I'm done.
Okay. Now, alkali and alkaline earth metals, they are two completely different groups. Alkali metals are group 1 and alkaline earth metals are alkali metals belongs to group 1 while alkaline earth metals they belong to group
Group 2.
2. Yes.
Okay. So you're saying alkali metals group 1 elements, then alkaline earth metals are group 2 elements. So
Yes.
what's the difference alkali and alkaline?
Yes, we will study this in the next slides. Okay, so have some patience. We will study this. Why they are called alkaline earth metals? We will study. So, what can you tell me the names of all alkaline earth metals?
Beryllium, magnesium, calcium, strontium, barium, radium.
Yes, very good. What is the symbol for magnesium?
It's Be. Fourth
Magnesium. Magnesium.
is Mg.
Yes. What is the symbol for radium?
Fourth
Radium.
is Ra.
Yes. So these are some uses of beryllium, magnesium, calcium, strontium, barium, and radium. We'll study that where do they found, where do they naturally found, natural occurrences. So they are found in the earth crust. Okay, that's why they are known as alkaline earth metals because they are found in earth crust. They are found in the rock structures. Magnesium, it is found in carnallite, magnetite, and dolomite. These are the name of the ores in which your magnesium is present. It is also extracted from seawater. If we talk about calcium, it is found in chalk, limestone, gypsum, and anhydrite. The formula for limestone is calcium carbon. The formula for gypsum is calcium sulfate, CaSO4, dot 2H2O. Okay. Carnallite is, you do not have to remember the formula of these words, but see that it is in carnallite, magnesium is also present.
Okay.
So write down where their natural occurrence.
Okay.
This is your periodic table. It is divided into 4 blocks depending on where the last electron goes. So this is your S block elements. These are my D block elements here in the middle of the periodic table. The right side of the periodic table we have P block elements, and at the last we have F block elements. So where are the alkaline earth metals present? Can you tell me?
What?
Where are the alkaline earth metals, that is group 2, located in the periodic table?
In the S block.
This one or this one or this one?
The second one.
Yes. So here we have beryllium, then magnesium, then calcium, strontium, barium, and then we have radium. Okay, so the outermost electronic configuration, valence electronic configuration for alkaline metal is Ns2, where N represents your principal quantum number. Okay, write down the electronic configuration of beryllium, magnesium, and calcium. So atomic number of beryllium is 4. So you have to write it like this: 1s2, 2s2. Do you know how to write this?
Yes.
So write down the electronic configuration for magnesium, whose atomic number is 12, and write it down for calcium, whose atomic number is 20, and then tell me the answer.
Mhm. Then you said magnesium and what? And calcium.
Yes.
Mhm. Yes. Done.
So what is the electronic configuration for magnesium?
So for magnesium, it's 1s, 2s, 2,
1s2, 2s2.
1s2, right? Yes, then 2s2, 2p6, 3s2.
And calcium?
For calcium, it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2.
Okay, now you can see that outermost electronic configuration is Ns2. Okay, then again one shell increases, it becomes 3s2. Again one shell increases, it becomes 4s2. And here we have 5s2 in strontium. For barium we have 6s2, and for radium we have 7s. Okay.
Yes.
Now this is a simple trick to learn alkaline earth metals. That trick is that big mice can scare brown rats. So the first alphabet of these elements, they are matching with this trick. So you can write it down for your remembrance.
Okay.
So this is a very important note. Basically, the students get confused in that beryllium is not an alkaline earth metal. It is a group 2 element, but it is not an alkaline earth metal. Beryllium is a group 2 element. Why? Because its outermost electronic configuration is what? 2s2. but it is not an alkaline earth metal. Why it is not? We'll study. Because it is not found in the earth's crust, and its oxides and hydroxides, they are not alkaline in nature, they are amphoteric in nature.
Please come again.
First of all, write down this point. Why beryllium is not an alkaline earth metal?
Okay.
This question comes up in your exam. I'm writing down the answers here. Because its oxides and hydroxides exhibit amphoteric behavior. While it should behave like alkaline, it should show the alkaline behavior rather than alkaline behavior. Amphoteric behavior means that it can act as both as acids and bases.
I'm done.
So where are the alkaline earth metals found? The elements in group 2, they are on the left of the periodic table. They are called alkaline earth metals. You know the names of these alkaline earth metals. Why they are called alkaline earth metals? Because their oxides and hydroxides are alkaline in nature. And the second point is they are obtained by electrolysis of the molten earths. That's why it is known as alkaline earth metals. Okay, not the alkali metals. In alkali metals are not obtained by electrolysis of molten earths. So write it down.
So I write that alkaline metals are obtained by electrolysis of molten earth.
Alkaline earth metals, right.
Okay.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Can you answer this question? Which of the following is not an alkaline earth metal?
Aluminium.
Yes, it is aluminium. So in the S block elements, we have two groups. Group 1 that is known as alkali metals and group 2 that is known as alkaline earth metals. So the electronic configuration is, outermost electronic configuration is NS1 for alkali and for NS2 for alkaline earth. They all are reactive metals, but they have low ionization energy. That means it requires very less energy to remove the last electron. Lose outermost electrons readily to form 1 plus ion to achieve stability, or 2 plus ion in case of alkaline earth metal to achieve stability. Because if we write beryllium, beryllium, it is 4. So we will write it 2, 2. They lose easily 2 electrons to achieve the stability. For magnesium, we write 2, 8, 2. So they easily form Mg2 plus ion, right? Because of their low ionization energy. They're highly reactive. Why they're highly reactive? They're highly reactive. They are not found pure in nature. They are always found in the form of ores. Write it down.
Okay.
Okay. So alkaline earth metal, they are your group 2 elements with the outermost electronic configuration of NS2. The first element, beryllium, it differs from the rest of the members and shows diagonal relationship to aluminium. Aluminium belongs to group 13, right? So by first element, it is not also known as alkaline earth metal. Beryllium is not an alkaline earth metal. Also, its properties are also different from the rest of its members. It shows the similar properties to aluminium. Okay, so the question may ask, land up in your exam like this, that why beryllium differ from rest of the members and shows diagonal relationship to aluminium. So what do you write? You have to write few points that beryllium, due to its small size and high charge density, okay, So you know that beryllium is smallest. Okay, it has the smallest atomic and ionic radius among the alkaline earth metals. So that's why its atomic radius is small. That's why its charge density is higher. Also, it prefers covalent bonding. It prefers covalent compounds rather than the ionic compounds which your other alkaline earth metals form. Okay, and also their amphoteric nature can act as both an acid as well as basis. So these are some properties which matches with your aluminium. BeCl2, KlCl3, they are your electron deficient molecules.
Right. So here we comparing the differences between beryllium and aluminium.
No, but we are not comparing the differences. We are matching the similarities between beryllium and aluminium. Aluminium also form covalent compounds. Aluminium is also amphoteric. The aluminium oxides are also amphoteric.
That is amphoteric, right? Meaning
Yes.
it possesses both
It can act as both as
acidic
acids and
nature.
bases.
Then here, the points that you wrote there of beryllium having a small size, and a high charge density.
This makes
What
beryllium
is it
different.
related to?
This I'm telling. This makes beryllium different from the rest of the members because of its small size and high charge density. It makes beryllium different from the rest of its members.
Okay.
That might have some different distinct properties which I have written here. Can you answer this question?
Magnesium is called alkaline earth metal because it is in the S block element. Yeah, it's D. The answer is D. It's an S block element.
No. It's called an alkaline earth metal. I have told you the explanation why it is called alkaline and why it is called earth.
Yes.
So what should be the answer regarding that?
Isn't you said that the alkaline earth metals are found in the S block?
I'm saying that magnesium is called alkaline because its oxides and hydroxides are alkaline in nature, and it is called earth because magnesium oxide is found in earth's crust. They are found in molten earth, right?
Okay, okay, so for this one, the answer becomes A, right?
Yes.
So what makes D wrong? Because D is also correct in a way. Isn't we say that alkaline earth metals are in the S block elements?
Yes, they are in the S block elements, but read the question. What is the question saying? Magnesium is called alkaline earth metal. Why magnesium is called an alkaline earth metal? Because it is an S block element. No. S block element is alkali metals also. So this is not the correct answer. Why it is called alkaline earth metal? This is the question.
Oh, okay, now I see. I see.
Write it down.
Yeah.
Okay, now these are the electronic configurations of all the other alkaline earth metals. They have two valence electrons. Okay, all these have two valence electrons. So NS2 outermost electronic configuration. Now this is your shell number or the period number, and it is known as your shell number or period number. The outermost electronic configuration would be like this. For barium it is 6s2, for radium it is 7s2, and this is your N, which is your principal quantum number or period number, because radium belongs in the 7th period, right? So let us read about the physical properties, that they are silvery white, soft, but harder than alkali metals, and they are lustrous. Lustrous means shiny. So they are soft, but they are harder than alkali metals. melting point and boiling point, they are higher than alkali metal. We are comparing it with the group 1 elements. Why? Due to their smaller size. They are strong electropositive in nature. Electropositive means they readily lose electrons to form plus two ions. So they are strong electropositive nature. Calcium, strontium, and barium, they impart characteristic colors to the flame. And the colors are brick red, crimson, and apple green. Brick red for calcium, crimson color for strontium, and apple green color for barium. Okay, so we will study the flame test in the upcoming slides, how it is done.
Okay.
Electrons basically they are excited when the light falls on them, when the energy of this flame falls on them. So the electrons are excited, and when they return to the ground level, they emit radiation. Okay, the color corresponding is this brick red, crimson, and apple green respectively. So what is electropositivity? Due to their large size and comparatively low ionization energy, large size we are talking about, as you move
Elect-
down the group, atomic size increases, and as you move across the period, atomic size decreases. Okay, so due to their large size, because S group, the here S block elements are present, which are larger as compared to P block and D block. So due to their large size and low ionization energy, they are strong electropositive elements, and on moving down the group, electropositive character will increase. So if I ask you which one is more electropositive, magnesium or strontium, so you will say strontium is more electropositive. Okay,
yes.
perfect.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Okay, so there are some other physical properties which are written here, that they have high melting points, they are harder, they are more denser than potassium and sodium. Potassium and sodium, they are so soft that they can be cut with a knife. They are so soft.
Okay.
Yes. And when put in flame, basically magnesium, it doesn't impart any color. Calcium gives dark red or brick red. Strontium gives crimson, and barium gives apple green color. They have two valence electrons. They are metallic and ductile. What is the meaning of ductile?
Ductile. Ductile, like when something is ductile, I think
It is
does
a
it mean
property of a metal.
since you say it's metallic, right?
Yes.
Then when you talk ductile, are you not now talking about that sounding thing?
No, that is sonorous.
Yeah, on the
Ductile means
on
its
the
ability to drawn into thin wires.
um. Then why do we have malleable at the bottom?
Malleable is that its ability to be hammered into thin sheets is called malleable.
Okay, so being my question now stands being ductile and malleable, like isn't it more like 1 point?
Yes, you can write it in one point.
Okay.
But they are different, right? Their ductility means their ability to drawn into thin wires. Malleability means they can be hammered into different shapes. It's your wish, but they are different, right? They are not same. And they are the properties of metals. And magnesium,
Oh,
the two elements, they are also metals to write down.
okay. Mm, the one that you cancelled, magnesium.
I'm talking
On
about the physical properties of the element.
yeah, here isn't on the screen that you shared physical properties. Here we have 2 valence electrons, metallic and ductile, right?
Yes.
Silvery white, right?
Yes.
Malleable.
Hmm.
Then on the left hand side, where it starts from have high melting points, are harder and are more dense than potassium and sodium, right? Then the second
Yes.
point, bottom, when it says the statement says when put in flame, then the points that there is magnesium cancelled. So I'm asking why is
Why magnesium is cancelled?
yes.
Because magnesium does not impart any color to its flame. That's why I cut it. Okay, so it doesn't matter that it gives white flame. It doesn't impart any color. So why we are writing it white? That's why I've cut it. Why? Because
Okay.
magnesium have a very small size. Due to its small size and high ionization energy, what happens in ionization energy? It decreases down the group. So magnesium have higher ionization energy. So magnesium requires larger amount of energy to be excited. That's why it is not possible in the Bunsen burner. That's why it doesn't impart any color.
Okay. Then the rest do impart that color change.
Hmm. Not color change, the color in the flame when they return to the ground state.
So for calcium, it's dark red.
Hmm.
Strontium, crimson, then barium, light green. Okay.
Light green also, or we call it as apple green also.
Okay.
So now next thing is the physical properties, that is your atomic and ionic radii. What is an atomic radii? Distance from the center of the nucleus to the boundary of the surrounding shells of electrons is called the atomic radii. So this is the atomic structure where this is the nucleus which is positively charged and these are my electron shells. Okay. So the distance from this center of nucleus to the boundary of this outermost electron, okay, outermost shell is called the atomic radius. So compare it with the alkali metal, they have smaller sizes than alkali metals, but overall in the periodic table they are larger. The atomic and ionic radii of alkaline earth metal they increases because they increases on moving down the group from beryllium to radium because the number of shells increases, therefore increasing the atomic radii. Is it clear?
Yes.
Okay. So the atomic radius of group 2 elements, it increases going down the group. What is the reason? Because each element's atom going down the group, it has an additional full energy level compared to the above one. So gives weaker forces of nuclear attraction and the atomic size increases. To see the atomic radius of beryllium, for magnesium it increases a little. For calcium it increases, for strontium also, and for barium it is the largest because the number of shells are increasing. In beryllium there are 2, in magnesium there are 3 shells. It is 2, 2, it is 2, 8, 2, and it is 2, 8, 8, 2, right? And so on. Clear?
Okay, so this is the question.
Yes, which option is correct?
Okay, so isn't we say that the trend in atomic radius, we say that atomic radius increases down the group, right? And
Yes.
we know that we start from beryllium, right? Going to magnesium, calcium, then strontium, right? So basically A is